Okay, welcome to the enigmatic data analysis part of the Millikan prep. I'm going to show you how to find what the size of this step is here. Okay, so see that step there? All these steps are roughly the same size like that. Okay, now one might imagine that the way to go would be to measure the size of each step and then average all those sizes. Okay, what I'm going to show you, you can mathematically prove this. Somebody proved it to me once. What I'm going to show you is just as good as that and far less painful. Okay, so this is what you want to do. You want to find, if you look at this thing, you want to find a place where you're confident about this step. I could go with this one, but I'm going to choose this guy, partly because it's easier to find. There's that step. I'm sure of that step. That's a step. And then all of these steps are a single upward step of those. They all look about the same size. This one, I think that's actually 2 steps up. And I think this is actually 2 steps down. So I'm suspicious of that. I'm suspicious. So I'm going to choose this guy to be my well-represented upper step and my lower step like that. Okay. Now, if you look, the difference between this step and this step is 1, 2, 3, 4, 5, 6, 7, 8 upward transitions. Now, this is one of these crazy things where, like, if you count the steps, I think there's 9 steps because that's not what's important, right? The thing that's important is how many upward transitions. Okay, so the upward transitions are 1, 2. We're talking about the fronts of steps. 3, 4. There's 5, 6, 7, and 8. Okay, so to figure out what these steps are, I'm going to average the high one, right? The high, right? And I'm going to subtract the average of the low. Right? And then that I will divide by 8 steps. Now you'll have to do this. This is getting you ready because when you do your graphing of your electrons that you measure in the virtual reality world of the Vernier software, right? You will get a graph if everything works right, if you do your math correctly, if your formulas are correct. In the best case scenario, right, you will get a graph that looks like this. It's got steps. And you're going to find a step there and a step there. Do this, 8 steps. Now, how do you average that? Don't read the graph. Let's just look for them. They'll be in there. There should be 3 altogether and then 2 outliers. The 3 that are all together are just above 40. Pretty sure that would be them right there, yeah? Isn't that them? Okay. And then there should be 3 that are just below 20. So let's look for those guys. By the way, they would be the 1, 2, 3. They'd be the 4th, 5th, 6th ones, right? Oh, there they are. Okay, so there's lots of ways to find them. So you will have to, when you do your actual Millikan lab, you'll want to sort the data like this, right? Make the graph and then find those steps like that. So this would be the average of the high. You would average those 3, right? And then average these 3. Averages make sense when the numbers should all be the same. Okay, so average those guys and then subtract, and that will give you your step size. Now I'm just saying, it's like about half of you will, when you come to your lab, you'll count these steps incorrectly. You'll say that there's 9, but remember it's the fronts of steps. The steps are the upward transitions. Okay, so just think of that. In the next video, I'm going to show you how to do the uncertainty.